Okay, so we've got everything we need to define precisely what logical consequence is for the propositional language, right? So we say that logical consequence, so there is logical consequence when there is no interpretation where the premises are true and the conclusion false. We have defined precisely the propositional language, right? And we have defined precisely what an interpretation is, right? So we've got all the ingredients, right? We can say that a conclusion A is a logical consequence of a set of premises gamma. Just in case, so here gamma is supposed to be a set of sentences, right? So A is a logical consequence of gamma, just in case there is no interpretation where all the premises take value 1 and A takes value 0, right? So there is no interpretation where all the premises, all the gammas take value 1 and A takes value 0, right? So this meshes with our previous ideas, right? Now we are going to give a slightly generalization of this notion of logical consequence. So very often logical consequence is defined just for multiple premises to single conclusions, but we are going to consider the case where we've got multiple conclusions, right? So we can have a set here on the right of the logical consequence symbol, right? Why do the, so there are like philosophical reasons to justify this use. We are going to do it just for very, very pragmatic reasons, right? That it allows us to express some facts particularly related to the concept of duality that we will explain later. Okay, so we will say that a set delta is a logical consequence of a set gamma, just in case there is no interpretation where all the gammas take value 1 and all the deltas take value 0, right? I repeat it. Delta is a logical consequence of gamma just in case there is no interpretation where all the gammas take value 1 and all the deltas value 0, right? Or in other words, in any interpretation where all the gammas take value 1, at least one delta takes value 1, right? So that's the idea. Now some examples. So come with me. So for example, the particular case, right? Our first definition for single conclusions is a particular case where the delta, the set delta in the conclusions contains just one element, right? So that A is a consequence of gamma means that the set containing A is a logical consequence of gamma, right? Now we can talk about valid sets, right? We can say that a set is valid when this set is a logical consequence of the empty set, right? And in order to see what this means, you have to look just at the right-hand side of the definition. So come back to the definition of logical consequence. So suppose that this is empty now, right? So delta is a valid set just in case there is no interpretation where all the deltas take value 0, right? So delta is a valid set when at least in every interpretation, at least one delta takes value 1, right? Examples of valid sets. Well, we've got that this is a classical validity, right? P disjunction negation P, right? This takes value 1 in every interpretation, right? So this is a classical validity. But this is a classic set, a valid set, right? Because P, the set containing P and not P, right? In any interpretation, at least one of them will take value 1, right? So this is an example of a valid set, right? And the same goes for the premises. So we can say that a set gamma is unsatisfiable, right? A set gamma entails the empty set when, and this is the dual notion, so suppose now that we've got only premises, no conclusions, this is valid just in case there is no interpretation where all the gammas take value 1, right? So you forget about this part of the definition now, right? So a set gamma is unsatisfiable just in case there is no interpretation where all the gammas take value 1, right? So for example, P conjunction not P is classically unsatisfiable, right? But also the set containing P and containing not P is classically unsatisfiable, right? Perhaps you can see that there are some symmetries here, right? we will talk about this later. So that's it.